As I may have mentioned, any of these orbitals, whether it is a 4d orbital or a 3s orbital or a 2p orbital, can hold 2 electrons. How many electrons can a 3p orbital hold? 2! Every orbital can hold how many electrons? 2! Every single orbital around an atom where there might be electrons can have, guess how many electrons in it? 2! Not 3, not 1, 4 is right out. It's 2. It's always 2. If you're ever asked in a dark alley, how many electrons can a 63Z orbital hold? There is no such thing, by the way. How many would that be? 2. Okay. Shouldn't be in dark alleys in the middle of the night. You're right. Okay. So what this means, and you guys have already done this. You figured this out for yourselves, which I think will make it stick better. You can figure out exactly how many orbitals, how many shapes, and how many electrons there are going to be at any of these energy levels. This is more knowledge and power than you thought than perhaps you were expecting for 6th period on Thursday. It's pretty exciting stuff. Okay. Tomorrow you will have a 5th quiz. You will be quizzed on numbers, fair questions include things like, how many orbitals on this main energy level, how many electrons in this orbital, how many electrons in this main energy level, how many electrons in this subshell. Have your terminologies straight. Be able to predict numbers of orbitals, electrons, and subshells from principal quantum numbers questions. Yes, sir.
All right. So the subshells are the
Yep.
I'm promoting to, I guess, this is subset F, I know that is
You mean like how do you name, like this is 4D, this is 3S?
Yeah,
Okay.
I never seem to go up for the number.
Okay. And then it's just the shape of the orbital. So the spheres are S's, the double drumsticks or dumbbells are P's, the quadruple drumsticks.
2 weeks.
Okay, there we go. The figure 8s are P's, the double 8s are D's, and then the squiggles are F's. And I can show you F orbitals. Let me pull up. And it's nice because this is always the first Google result. Yes, rotation, that's what I mean. Where is that? Well, it used to be the first one. There it is. That's not it either. Yeah, you didn't want to see that math. No, you don't. Okay, here we go. So there's an S. The S orbital there is rotating, though you would not really know it because it's a sphere. Ah. There is a P orbital. And that first column is what's called a density diagram. So each dot represents a probability of finding an electron. So the darker the area, the higher the probability. And when you sort of smooth out the bumps in that mathematically, what you get are those little, they represent them as more double spherical, but that's not what I usually see. So here are the P's at the third level. And then let's go to the D's. So they're, you know, kind of those double whatevers. There are the D's. There's the double drumstick donut. No. I expect you to know the shape of the S and the P. That's it.
I was hoping like double drumstick
No.
donut.
No.
That's the double square.
There is another site that's got the F orbitals though. Here it is. This has got to be it. Yes, here they are. Okay. SPD, and there we have the weird little, you know, drumstick and donut. Here are the F orbitals. Yeah. So you can have these. You do not have Java. Oh no. We can't see them? Okay, let's try Internet Destroyer. Okay, apparently we can't see them on here at all. Well,